Okay, let's start. So hello everybody, I'm Catalin Tudose. Thank you for participating to this webinar organized by LocalHost. We are going to spend about 1 hour together to discover the most important things about Java networking working with sockets. I will switch between the presentation and the code within this hour. So I will present both some theoretical conceptual things and I will run together with you a few examples that will be significant in our context. Please keep in mind that at the end of this session, you will be able to address questions. So if you have something that you would like to ask, please keep it in mind and address the question at the end. So I will point out a few things. You may be familiar with a few ones, but we would like to fix very well the concepts about the OSI model that is shaping the idea of a network. It is divided within 7 layers. From the bottom one, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. It models some communication between open systems. OSI means open system interconnection. And you may imagine that whenever you have some communication within a network, you are creating some virtual circuit at each of these 7 layers. Another model, which is more practical and that we are going to detail a little more, is the TCP/IP model. Of course, it is also a layered model. It has only 4 layers: link, internet, transport, and application. And it is more practical and technically more in line with modern network implementations. So that's why we are going to detail it a little bit. What about the link layer? When we are talking about the link layer from the TCP/IP model, it corresponds to the physical and data link layer functions into the OSI model. What are we talking here about? We are talking about modulation, about how the signals are sent, about if you have a connection through optical fibers, through Wi-Fi, or through some other kind of physical device. So at this level, we are talking about some common protocols like address resolution protocol and neighbor discovery protocol. The internet layer, which is the second one from the bottom, corresponds to the network layer on the OSI model, and it talks about traffic routing, about traffic control, about fragmentation, logical addressing. We are going to briefly present what logic address means, and the common protocols at this layer, at the level of this layer, are IP, ICMP, IGMP. The transport layer corresponds to a layer with the same name in the OSI model. Here, we are discussing about message segmentation, acknowledgement, so you have to understand if some information that you have sent has correctly arrived at the destination. You may ask for resendings. At this level, at this layer, at the level of this layer, we are doing some error detection and correction. We are reordering messages in case that they have arrived in some wrong order. At this level, the common protocols are Transport Control Protocol, or TCP, and User Datagram Protocol, UDP. The big difference between them is that Transport Control Protocol is a safe protocol. What does it mean? It means that it will always guarantee the delivery of the packages. It means that it is used when we are accessing the internet. When we would like to access some web page, we have to be sure that the communication is reliable. So it is a reliable protocol. We have to make sure that the information has correctly arrived to its destination. In case something is wrong, as we're saying, we are detecting the error, we are requiring resending. UDP is an unreliable protocol, so you cannot always be sure that your messages arrive to destination. And in this case, a natural question will be why and when should we use it? We are going to use UDP, for example, for live transmissions. So if you are broadcasting an event, you have to be in real time. If something goes wrong, if some packages of the transmissions are lost, you cannot go back. So UDP also has its own applications. And at the fourth level, we have the application layer. Here, we are talking about things like electronic messaging. Our emails are exchanged through this application layer. The network management, remote access. So if you are going to do some VMC connection remotely, some remote desktop, if you are familiar with it, this is done through this application layer. Common protocols at this level are TLS, SSL, FTP, file transfer protocol, DNS, domain name system, and of course, HTTP, which is accessing the web pages. SMTP, this simple mail transfer protocol, this is used by the email transmissions. And we were saying that we are coming back to addressing to the IP level. Each device on the internet has an IP address. And in use, there are two versions of this IP, IP version 4 and IP version 6. IP version 4 uses 32 bits for the internet address. So this means that the format is ABCD. Each of these ones, ABCD, are in the range 0 to 255. So it means that we may have up to around 4.29 billion devices inside the network, 2 power 32. With IPv6, we have up to 2 power 128 internet addresses in the network, because this is represented, such an address is represented by 128 bits. And we have some special addresses. Our own local host is 127.0.0.1, while the broadcast, meaning all interfaces on the network, are represented by 255, 255, 255, 255. In order to make the communication, we need the internet protocol address of the machine, and we also need a port number. This is a 16-bit unsigned integer from 0 up to 65,535. And in order to communicate with some process on a given machine, you will need the IP address, the transport protocol, and the port number. So you are going to say, I would like to connect to this process. You are going to need these three things. And you have to make sure that there are no port conflicts. So meaning that multiple programs do not attempt to use the same port number on the same IP address, because it is not going to work. It will say address bind already in use. And we are introducing what a socket means. What's a network socket? It is like an endpoint, an internal point for sending or receiving data between computers. So it is like an entry into a table that represents that internal endpoint, and you are going to open such a socket in order to make the communication. So looking to the Java classes, that are representing IP addresses and sockets. There is a Java base class called java.net.inet address. This is the base class, and it has two subclasses, inet4 address and inet6 address, corresponding to the two versions of the IP protocol that we have introduced, IPv4 and IPv6. And there is also a class called inet socket address that represents the IP address and the port number. And we remind that in order to access a process, you need the IP address, the transport protocol, and the port number where such a process is running. So after this brief introduction about the main networking concepts and about the main Java classes, I'm going to switch now to the practical demonstration, the first practical demonstration. So that we are going to make some demo to put in practice what we have already discussed. Just a moment. Okay, I think that now my IDE IntelliJ is showing. Okay, so we were discussing about internet addresses, about sockets, about communication endpoints, and this is the first example. It is doing something very simple, and you see that it is called LocalHost. LocalHost, of course, it suggests that it is trying to get some information about the local host. And what we have here, we have this inet address class that we have just introduced. And we have also imported this java.net.unknown host exception, because we may expect that in case something goes wrong, an exception is thrown, an unknown host exception is thrown. So what are we saying here? Say inet address get localhost. So this is the name of the class. And we are asking, please give me the local host. Let's see how it works. So you see that I have executed this program, and it is showing the host name and the host address. Here you see that this is the name of my computer, and this is the IP address of my computer. What should we comment here? Additionally, inet address is the name of the class, and getLocalHost is a static method. In fact, it is a static factory method. So whenever we are executing inet address.getLocalHost, we are expecting to get the local address, and from here we are getting the host name and the host address and just displaying them. So this is something very basic to show how we can get information about the local host with the help of Java networking classes. And remember that you are able to find all these classes into the java.net package. And we have used this INET address and unknown host exception. Remember, this is representing the internet address. And this is a possible thrown exception in case the host is not found. So I'm going to move to the next example. This is called GetHostInfo. Let me first try to execute it, and we'll explain it. It says that it is looking for www.google.com and is providing us the address, the name, and the address of the host. Why is it looking for Google.com? It is looking for Google.com because it is receiving this one as argument. And in order to show this, we look here into the parameter, and you see that it is providing this www.google.com as program argument. And what it is saying, first of all, we are checking that we do have exactly one argument. Our program needs exactly one argument in order to run. Then it says, okay, if you have passed this argument to us, let's see what I can find out about it using inetaddress.getByName, and it is passing this argument 0, which is exactly www.google.com. And then it is providing exactly the information, the host name and the host address, meaning exactly what you see here. Host name is www.google.com. Host address is 64.233.169.99. If you would like to find some other address, let's look here. LocalHost.com. And I am re-executing this program. So you see that the address of our www.LocalHost.com is 54.154.175.230. Let's try to show that we are really on the safe side. So you see, if I have removed the program, it is not executing, it's just printing this message and it is exiting. But let's try something that is not working. Let's say www, and we pretend that we wrote here something wrong, and let's execute it. Oh, it seems that this one exists. Let me try to something that does not exist. You see, we have deliberately triggered an exception. Remember that unknown host exception that I have told you about. Here we have introduced some host that does not exist. It means that if we look here at line 12, when it is trying to get the address by name, this method is going to throw an exception, this one, and we are simply throwing it and printing the information. Okay, let's finish with this example in a more optimistic and working manner. Let's write here localhost. So I would like to get the information about my own machine again. So you see, it is getting 127.001. This is exactly the IP address that I was telling you that it represents the local host. It is a special IP address. So whenever you are on your local machine, your own machine is 127.0.0.1. Okay, I will move to the next example. So you see that we would like to get some socket information. Remember that we have introduced the INET address class, and then we have introduced the INET socket address representing a socket, a communication endpoint. So we are going to get by name some addresses here, for example, again, using this inet.getByName. And we are going to do this for our www.localhost.com. And we are going to output the information. We would also like to do something more. We would like to open a socket here. After getting the address, you are going to try to open a socket on port 80. So an end communication endpoint on that port. Remember that in order to communicate with a process, you will need to have the IP address, the transport protocol, and the port number, and the port number is here 80. So if I am executing this, so you see we are getting information about the host, including the name of the host and the IP address, the port that is represented by that socket. The same here with the local host. Okay, I'm going to move to the next example. GetAllByName. Let me execute it here. See, it is saying array index out of bounds exception because it is looking for an argument. So I am going to go here to the configurations, and I will say program arguments www.localhost.com. We execute it. So it is getting the host, and it was possible that there was more than one address associated with this host. In our case, it is only one. So we are using this factory method, inetaddress.getAllByName. We are passing this argument, which is www.localhost.com, and we are passing through the possible addresses. Here we do have only one. I think this is pretty straightforward, as we have already discussed, already presented the first three examples. And I'm going to show how to ping. Probably you are familiar with pinging. When you execute the ping command, you are trying to see if some host is reachable. And this is exactly the name of this method, is reachable. Let's execute it. Okay, we have to provide some argument. I'm going to say again, localhost.com. Trying to re-execute it. it is also expecting for a timeout, let's say here 50 milliseconds, and we would like to see if our LocalHost.com is reachable within 50 seconds. And says LocalHost.com and the IP address is 54.154.175.213 is responding to ping within these 50 milliseconds. No, says it is too short. Let's try a larger timeout. No. Let's see, maybe something wrong here. I will try another host. There may be something wrong with the server at this time. Let's try with Google. So you see, Google has responded to our ping within 50 milliseconds. So there may be something wrong, some problem on our website server. Let's try here to reduce the interval. Is Google responding within 50 seconds? No, the timeout has been too short. So if we take a look here, we see that we are doing two things, two important things. We are getting this INET address using the GetByName factory method from the INET class. And we are asking ourselves, after having received the address, which is the host address and is it reachable within that interval of time? It means that it is simply pinging that address and it is getting the information, is it reachable or it is not reachable within that timeout. Okay. And before moving back to the conceptual presentation, I would like to show you this sixth example. This is a port scanner. What does it mean, a port scanner? A port scanner, you are scanning, as the name says, you are scanning the ports of some given host. And you would like to see if something is open there. Let's try to execute this program. I don't know if it has arguments. Here it says a program must get exactly 3 arguments: server, start port, and end port. So I'm going to scan www.google.com, and I am going to scan from the start port 70 up to end port 90. And let's wait a little to see if it finds out something. It will take a few seconds. Okay, it says port 80 is open. It is going up to port 90. Okay, so from within this interval of between ports 70 and 90, port 80 is open. So it means that accessing the google.com web server, port 80 is open. Is it something that we're expecting? Of course, it is something that we were expecting because port 80 is the HTTP port. And of course, the www.google.com server is waiting for a connection on port 80. And when we are scanning the interval between 70 and 90, that port number 80 will be found as open. Let's try something more. I'm going to write here localhost 70 to 90. Let's see if something is open on my side. Is there any web server accessible on my own machine? Nothing so far. Oh, seems nothing is running on my port number 80, so I do not have any web server installed here. It was natural that it was found on the www.google.com web server, because that server was expecting for a connection from our side. But on my machine, I do not have any web server installed, so nothing was found on port 80. But let me try something else also on my machine. So I will keep this server localhost, and I will say 3000. So I'm going to scan my localhost between ports 3300, 3310. I'm running the program again. Says port 3306 is open. Why is that happening? Because on my machine, I do have the MySQL installed. MySQL is a database server. And the default port on which this database server is running is port 3306. And it is natural that now, scanning between 300 and 3300 and 3310, I found this port open. But of course, it is not going to work on any machine if you don't have any MySQL installed on your machine, or if MySQL is running on some other port and you execute the same program on your own machine, you are not going to get anything, just like it was happening when I tried to see if something is running on my machine between port 70 and 90. Let's have a closer look at the program, because we haven't done this so far. First, we see that the program always needs to get exactly 3 arguments: server, start port, and end port. So the host is the first argument, start port is the second argument, end port is the third one. And what are we doing here within this loop? This is the key, this is the secret of this program. So we are passing through this loop, we are browsing the ports from the start to the end, and we are trying to create a socket here, and we are trying to connect within a timeout on that socket within 1 second. There are 2 possible things that may happen here. To have something running on that socket, in which case this message is printed, as you have seen, for port 80 for www.google.com and for port 3306 for my own machine. Or if nothing is running here, the connect method is going to throw exception. And we are just catching this exception and we're not doing anything. We are passing to the next port until we arrive to the end. So this is a simple port scanner with the help of which you can try and scan all possible open ports for a host in a given interval. Okay, for the moment, we have discussed a lot of examples. Let's go back to our presentation to point out a few more Okay, I think the presentation is on now. And I'm going to discuss a few more conceptual things and we'll make some other demonstration. So about the TCP protocol, I was saying that it belongs to the transport layer and it is a reliable, you see here, reliable flow. It provides a reliable flow of data between two computers. It means that it is a safe protocol. It means that you may have the certainty that data is delivered and nothing is lost and everything arrives in the expected order. So it is like providing a point-to-point channel for applications that require reliable communications. And we say here that it is a connection-based protocol. What does it mean? It means that the two endpoints that are communicating do have a dedicated connection. You may have an analogy with a phone conversation. So you pick up the phone, you dial the number, and on the other side, the called person is answering. And right at that moment, you may say that you have established a connection between you and the person you are talking to. So this is a connection-based protocol. You do have a dedicated connection. So this is how things are happening in a real world when you try to transfer something through the internet. So you may try to transfer some information for a website, and you do have a dedicated connection with that website. So you are establishing a connection with whatever, let's say www.google.com, and through the internet, the information is arriving to you through this dedicated connection. And here, in order to start this conversation, we have to pass through this three-way handshake. You see here sequences of signals that are exchanged, say from the client, meaning from our side, we are trying to access a server. What does it mean? It says client, when it sends that SYN message, it says, hey, I would like to connect to you. And the server is responding SYN ACK, meaning, okay, I have received your request. I am ready to discuss with you. And client says, okay, everything is fine. I'm going to give you my acknowledge. And now the connection is established. So we have SYN ACK, And if you would like to make again some analogy with a phone conversation, say, hello, it is me, whoever, oh, hello on the other side, and we start talking. So this is the three-way handshake that is initiating a TCP connection. And you see here that there is also some four-way disconnect. Whenever you have finished your conversation, you said, oh, okay, I would like to finish from the side of the client, say fin. The server responds with two messages, acknowledge and fin, and say, okay, I acknowledge that our conversation has been finished, and we close the connection. And if you are going to make the analogy with the real phone conversation, it's like, okay, we have discussed whatever we had to discuss, and now we say goodbye, talk to you later, okay, goodbye, and we are finishing our conversation. And would like, before moving back to the second part of the practical demonstration, we say that we would like to demonstrate how such a conversation takes place through the TCP. So on the server side, we are instantiating a server socket with a port number, so that server is waiting for connection, invoking this accept method that is named here. On the side of the client, we are instantiating a socket, and we are attempting to connect to the specified server on that port number. And once the accept method returns a reference to a new socket, you are going to have a connection between the client and the server. And I'm going to move back for two more examples. I think you see again my IntelliJ environment. So here we'll have two more examples. We have a greeting server and a greeting client for example number 7. Let's run them. Okay, it is expecting some port number, let's say something that for sure is not in use, 8085. So you see that our server is waiting for a client on port 885. And if we, okay, we have to provide localhost 8085. Okay, so what you see is that we have established a connection. So here, the server was waiting for the client on port 8085. And when we have started, the client says, okay, I will connect to localhost on that 8085. We receive this message from the server. We sent this hello to the server. The server has replied with thank you for connecting, bye, and the connection between the client and the server has stopped. So it is just a greeting client and a greeting server. The client connects to the server, says hello. The server replies, thank you for connecting, bye, and the connection ends. just to note that meantime, this server has already stopped its execution. Why? Because we have inserted this timeout here. So if nothing happens within 30 seconds, meaning that if no client is connecting to the server within those 30 seconds, then the connection, then the execution of the server will end. So just to point out what is happening here, we are initiating this server socket, set some timeout of 3000 milliseconds, meaning 30 seconds. And you see here in some loop, we print waiting for client on port, and we are executing this accept method. This is a blocking method, meaning that our program will not advance if no connection from the side of a client is received. So whenever the client has connected, we move forward, say, okay, receive connection from whoever has connected. We receive the information from the client. It is this hello that we are printing. Then we reply, we send back to the client, thank you for connecting, say bye, and we are closing this server. What's happening on the side of the client? We are creating the connection with the server here. We say connected to, and we have this output that we're sending here to our server saying hello from, meaning exactly this one that the server has received. The server answers, server says, we are printing whatever the server has replied, and we are closing the connection. You are closing the client. So this is practically a very simple client-server protocol, a very brief dialogue. The client says, hello, the server replies, thank you for connecting, bye, and then the connection ends. And we do have a last example. Echo server, echo client. Let's try. I also need some. Okay, it started on, the server started on 8,802. And we are also executing this client. So the server has started. Once we have executed the client, the server says, okay, I have received this connection from the local host and says, I'm ready. Hey, client, I have accepted your connection and I am ready for a dialogue. So it is an echo server and an echo client, and you see that whatever I introduce here, it is echoed by the server. Are you there? It is replying with the same. Are you there? Are you repeating everything that I say? Okay, so this is how things are happening. We have a dialogue, but the dialogue consists only of repeating whatever the client has said. And this is pretty similar to how things were working. So we are initiating here the server and announce that it has started. And within this loop, we are accepting connections and we are exchanging. We have an input buffer reader, meaning what is coming as input to the server. And once you decipher what you have been told, you reply here. So you read from the input and you reply with the same thing back to the client. Whatever you have read here, you are sending back to the client. And on the side of the client, it is something similar. And say, okay, I write here and I am displaying whatever I have read. Let's see if we print here quit. We don't get any reply because you see here this execution of quit stops our client and it disconnects from the server. So this is the last example that we wanted to demonstrate to you. So we have pointed out the most important things about how a network is working, about the layered structure of the communication, about IPv4 and IPv6 addresses, about port numbers, about the main Java classes that are used for communication. And we have had a lot of examples showing how to work with these classes, how to scan ports, how to get information about a particular host, and how to make an application that is a client-server application. It shows how the interaction between a client and a server through a given protocol takes place. So as we have finalized our presentation and our practical demonstration, I'm looking forward for questions from your side. Somebody is saying here that I haven't used INET4 and INET6 classes. Why? INET4 and INET6 are subclasses of that INET address. And you see here that I will go back. You see, I am using this factory method. So whatever this factory method returns is either an INET4 or INET6 class. Let's write here to see exactly what is the class name of the returned internet address. So I'm going to so you see, there was no need to explicitly use some INET4 or INET6 because this is a factory method. We have constructed our object not through the constructor, but through calling the factory method. And this INET address get localhost factory method has in fact, returned one of the subclasses of INET address. In fact, it is a INET4. So it is smart enough in order to provide you the class that is really needed. INET is an abstract class. It also has some methods here. So GetLocalHost is a factory method, and it is providing back one of the subclasses, which may be either INET4 address or INET6 address. Anything else?
Catalin, we also have a question from Mikal. What about non-blocking solution?
Somebody is asking about non-blocking solution. This is some different topic. Yes, our solution using that accept method is a blocking one, meaning that the server is blocked waiting for the connection from the client. Which alternatives do we have? We may have the alternative of multi-threading, meaning that whenever we have a new client, we open a new connection. Or we may have the alternative of asynchronous programming that will also be non-blocking. But this is some different topic. What you have seen here is indeed blocking solution. So the server is waiting with that accept method blocked so that a client connects to it. Anything else? I have feedback formula here. We have a question, what if we have more than one Ethernet adapter? What will INET address get localhost return? It will return one of these addresses. It is not sure. It is not deterministic which one of the addresses. It will bring you back one of these addresses. If you would like to get more than all of them, you may use that GetAllByName. And says RMI versus socket. In Java, this remote method invocation has another particular name. It is called RPC, remote procedure call. Yes, it is possible that we use remote procedure call in order to make this communication between the client and the server, but there's also some different topic. Okay, thank you too. Okay, great. Thanks everyone. Thank you. Bye-bye.